everyone. Hi guys, Faris here. So before that, Assalamualaikum warahmatullahi wabarakatuh, and welcome to my channel. So today, I will be doing a project presentation for my course, which is Embedded System. And before that, my metric number is 2311779, and I am an International Islamic University Malaysia student. So what will be the project about? So regarding the course, which is the embedded system, so we need to make a system that is embedded into our electronical or appliances daily uses. So basically what I want to say is that the first thing, what is my project? My project title is the pet feeder and water alarm system. So basically it has two functions. One is it enables to replicate what is the portion sizes for your pets, and also one of that is a water alarm system. So basically if the water is running low, will go on, that's all. So, and why do I have to do this project, and why does it matter to the pet society? One of the things is that the problem with pet owners is that they can be somewhat irresponsible when it comes to giving food and giving water supply to pets at an actual time. Not the timing is not fixed. So that is one of the things that we need to fix. So basically this system is paired with a lots of component, but it's just using Arduino Uno R3. So basically that's the microcontroller. So it allows pet owners to give water and also food at a designated time. So it reminds them regarding all the things that they have to do during that time. So that's that. So let's go to our project. So welcome back. So today this is my project, which is combined with a lot of things. As we can see here, we have an FSR, we have an I2C LCD, we have a potentiometer, we have an red LED, we have a green LED, we have a piezo or buzzer, we have two buttons here, and also we have a servo. And the most important thing is our microcontroller, which is the Arduino Uno R3. Basically that's the most basic thing, but you can also use Arduino Mega, it's up to you. So that's one of the thing. So what is all the component here? I want to tell you a little bit about all the components that is listed here. So let's go to the first thing. We have the digital input. So basically digital input, we have two, which is two buttons here. So we have one button is connected to D2 and one button is connected to D3. So the D2 one is actually the feed button, and the other one, which is the D3, is actually the alarm button. So that's two of the main things. It's very simple connection, where the left side, the bottom left side is connected to resistor and goes to the ground, and the right side goes to the 5V. Next we go to the digital output. Digital output is very simple here. We just use two LED. First is the red LED, and also next we use the green LED. So the connection is very simple. So we also have cathode and anode. So the cathode, which is the shortest one, is connected to the ground, while the anode, which is the longest one, we connect it to the resistor and also goes to the pin. So basically a red LED will go to the digital 8 pin, and also the green LED will go to the digital 7 pin. So next, we move on to the analog part. We have two types of analog here, which is first is the input and second is the output. So let's go to the analog input. Analog input, we have potentiometer and also the FSR. So what is the potentiometer? Potentiometer is to actually regulate the sense variable of voltage between 0 and 5 volt. So that converts to a digital number so that the UNO can use, which is 0 until 1023. So 1023 until that. So the connection is very simple. So we have 3 pins. The first terminal 1 is for ground, the terminal 2 is for 5 volt, but the middle part is called the wiper, which we can adjust. So the wiper will go to the A1 analog pin. Next is the FSR. FSR stands for force sensing resistor. So basically we have 2 pins here. Basically we can just connect them directly, but I want to show you a very simple method, or very much appreciated method, which is we use the voltage divider here. So we have 2 terminals here, voltage terminal. We use a voltage divider where we put a resistor. Before the resistor, we connect it to the analog input. Then after the resistor, we make it to the ground. Then for the next part, which is the next part, we connect it to 5 volt. That is it. So what is FSR actually? So FSR is used in this project to sense how much weight does the water is. So basically, if the water is low, it can sense that. If the water is high, it can sense that. That's all. So why not use like a, like not weights, but maybe a sensor that can detect the water's height. Why not that? But using that is much more complicated to understand, and also complicated for you to understand. So basically the FSR here we put so that we can just use the weight of the water. It's very simple. So next we go to the analog output. Analog output, we also have 2 here. We have piezo and also we have servo. Go to the piezo side. We have just simple connection, the +1. We go to the digital 6, which is the PWM. PWM stands for pulse width modulation, and negative goes to the ground. Piezo just make a sound, that's all. Then we go to servo. Servo, we have 3 pins here. The first pin is ground, second pin is power, and third pin is where we put it to digital 5 pin, which is also a PWM. So servo is just to move things. So next is the most important part to show our display. We have an I2C LCD. I2C LCD, here we have 4 pins, and I2C stands for 2 wires. So basically we have SDA and also SCL. SDA for data, SCL for clock. Ground is ground, VCC is 5 watt. Okay, so basically that is our system. So how does this operate? We have 2 buttons here. So basically if we press one button, we'll go to the feeding system, and the next button is for the alarm, which will operate automatically, depends on the water level based on the FSR value. So let's move on to the coding. So we have here the Arduino IDE system. So it's an environmental system for Arduino itself. So let's move on to hashtag include, which is the library that we need to use. So we have three libraries that we need to use. The first one is servo.h to control the servo. Liquid crystal I2C is for the liquid crystal, which is the LCD that we see before. And we also have y.h. Y.h is very important for I2C connection. Next we go to the variable here. So basically, as you can read here, this is just to initialize where our pin is. And also the liquid crystal, we just need to put 0 by 20, depends on the connection and also the model. So basically we use 0 by 20 here, so that needs to be the same. Then 16 and 2. 16 is the amount of what do you call it, column that we have. Then 2 is the amount of row that we have on the LCD. So that's that. And when we call servo, my servo, this can be anything. It can be also maybe a P alarm system here, variable, anything. So then next we just initialize our connection. Then next, this is also another variable that can be helpful for our system. We have position here, the FSR value here, the potential value here, the angle value, and the count value. Count is very important in the system. So why do we put position all towards 0? So basically it's not to initialize them pin 0, no, but as when we reset the system, so that the position all goes back to normal. That is it. So then we have void setup. Void setup is just to set up our system. So basically pin mode is very simple. It's just want to use set the pin for our components, whether output or input, that is all. So we use input pull up here, so that the first things that it detects is not low, so it cannot mess up with the system. Actually, we can use we can also use input, but later on there will be some problems. So then we have LED as the output and also the buzzer as the output. So as you can see here, we have the my servo. So attached is where the servo pin here, servo pin is. So basically servo, as we can recall, servo is at digital 5, and dot right is the position that it needs to be. Then we have serial dot begin, is just to send data to serial monitor, and also digital write. So basically digital write here is we want to put the red LED and also the green LED to low, so it will be turned off when we turn on the system. So then we have the LCD settings, very simple. Then the LCD loop. So basically we have two functions here, void functions. First we have read inputs, and also the second one we have button check. So let's move on to that. So basically when the system goes to the loop, it will go first to the LCD.setCursor00, the first initialize the placement, initial placement in the LCD. So it will be will display pet feeder V1.0. Then next we go to the read input, the read input function. So we have two, which is port value and also FSR value. So what is that? Actually it is to read what the potential pin and also the FSR value tells us. So in terms of what can we see, so I just put a serial print so that it can send over the serial monitor. Then we have also angle. Angle here is just map port value 0, 1, 0, 2, 3, 0 and 19. It's very simple. So what does this do? It's just a mapping system where we put the port value from potential value from 0 until 1, 0 to 3, and also the angle from 0 until the 90 for the servo. So next, button check. So as we can recall from void loop, after it goes for read input, it will go to button check. Button check, first button is to check whether the button for feed is high. If button for feed is high, it goes to the feeding. But if one of the other statement is that FSR value is low, less than 100, and count is 0, so we set that. Just play a buzzer here, play the buzzer, and set water low system. Next, if PB alarm is high, basically if the button for alarm is high, then it will do this operation here. So basically, if button alarm is button no alarm is high, so basically there will be no buzzer play into the system. So basically that's very simple. Then we have the else if FSR value is more than 100. FSR value meaning that the FSR value itself is more than 100, meaning there is water on it. So they will display water okay. Then this is very important where count 0 is crucial here. So as we can see, we have count 0 and also count 1. So what does that mean? So basically, if FSR value, if we move on to this part, which is count 1. So basically, if it is count 1, then after that, FSR value less than 100, if the water is still less than 100, it cannot play. So I will show you the project as example in the next time, but I just want to show you what this can do. So basically, I will show you count 1, and also this statement will show you count 0. So basically, if the FSR value is less than 100, it's more than 100, meaning that there is water there, so it will reset back count to 0, so that when the water level is low, the alarm can play. So that's that. So we go to the void feeding function. So basically, we have set cursor. It's very simple. We show you feeding time. Green LED will be high, which is the green LED will be on. Then my servo.right angle. So angle is from the potential meter value, which we put over here, which is angle map 0 until 90, 0 until 1023. So it will trace that. So then we just play a simple buzzer, and then the green LED will be low. So that's that. So that is boring. So let's move on to our example. So basically, for our example, this is here. So I just need to run. This is our code. It's very simple and also the same as the IDE. I just copy paste. Then I just need to start the simulation. So okay, as you can see here, the alarm is played. So basically, if I want to set off the alarm, one button is to, yeah, so when we press this button, the alarm will be off. So why doesn't it goes on after the alarm is off? So basically, that's where the count component is crucial. So basically, when count is 0 and when count is 1, that's crucial for this system. So basically, if we put the water, let's say 10 newtons water, right? So will be water okay. So when water is okay, then let's say if the water is back to 0, then read, and then the buzzer will go off. So that's the count statement. It's very important. Next is for the potentiometer value. So we can set how much food can we feed our pets. So basically, we have 0 until 1023, or maybe in a simple term, 0 until 90 degrees. So basically, if I put it here, maybe it's maybe towards 75 degrees, right? So until 75 degrees. So if I press over here, what will happen? It will go feeding time. So yeah, that's the alarm. So I just press it again. We'll go to 75 degrees. The gate will open and the buzzer will play. And also, one of the main things that okay, so the green LED will turn on. So before this, if the potentiometer is 0, right, so the red LED will turn on, and that's very simple. Then I think that's it for my project presentation. So thank you for listening, and I'll see you guys in the next video. Bye.